Hi everybody in Research Methods. We are going to cover a week's worth of material in this video because I am going to keep it simple for you. So, in other words, if we were in class, you would have to know how to draw all these charts and graphs and everything. There's a few different things within this section of the reading packet. You may look at the pages 89 and 90 and say, well, that's only 2 pages. You know, front and back, one piece of paper, but really, like most things we do in this class, it's more complicated than that. So, I am going to keep it simple, and you will not be graded on the exam for your ability to draw the charts and graphs because you really need to see me do it in front of you, and that can't happen. So therefore, you will just get credit for that automatically. So let's get started. We're going to talk about independent and dependent t-tests, but also in the form of ANOVA. You remember that from a previous exam? Analysis of variance, multiple t-tests. So here's what I want you to know. We're going to start by talking about between group designs. If you think about that, what is the difference between my two groups? Males and females, people who are under 30 and over 30, maybe between high school and college students, people who have jobs versus people who don't, people who play video games versus those who don't. You're going to have 2 separate groups of people. So that's a between group design, page 89 of your reading packet. Now, let me tell you what it is that you need to know to get this right on the exam. And by the way, most of you are doing this for your paper. Once you do your surveys, you will see that you are probably splitting them up into 2 categories to make it easy and to make the testing easy as well. Not just the concepts, the testing also. So, let's get started. It certainly helps if you can get random people. Like, not all your males are friends of yours and your females are people from school. That wouldn't be random. If you can get people at random, that's even better. Also, this is not going to be on the test, but there is a cause and effect problem. Just because I found results does not mean that one factor caused another. Also, do you need a control group, or is it just okay that you're doing males versus females or young versus old? Do you need in your study a group that gets nothing, none of whatever it is you're testing? That's not really relevant to our class that much because I don't think anybody's doing an actual experiment, just a comparison. And then the 4th thing is external validity. Let's say in your study, males and females really are different and you proved it statistically. Does that mean the same is true in real life? Or is it just that it's true for the people you studied? Anyway, let's get started. A1. I know it's a steak sauce, but other than that, we're talking about 1 factor, but 2 groups. So, how did people do on my survey about gaming? I want to measure whether you're in high school or college. Maybe that's my topic. There are 3 ways to do that. A1 is a simple randomized design. What that means is I'm going to randomly get people who are in high school, randomly get people who are in college. Now let's be honest with each other. If that was your topic and your study, you probably wouldn't be getting random people. Instead, you would get people that you know. So in a perfect world, yeah, randomized. But in reality, we just get people that we know. A2, stratified. Is it important that you get a certain percentage of people to represent your population? Disabled versus non-disabled? Well, the majority of people are non-disabled. Maybe at your workplace, there's more females than males working there. Maybe it's like Forever 21 or a store like that. Wait a minute, didn't we say they're going out of business? Anyway, let's just pretend. I might want to get my study completed with more females than males in my sample. So, that is stratified. But matched. Might it be important that you get an equal number of each group? High income people, males, honor students, or whatever. So there are 3 ways to set up a study which is probably the way almost all of you are going to do that, where it's going to be Group A versus Group B. Now here's an important factor. A person cannot be in both groups. So, for example, do you live at home or did you move out? Well, what if you still live at home part of the time, but you also have an apartment? I don't know what group you'd be in. Do you smoke or not smoke? Well, once in a while. If that's a person's answer, they can't be in your study. So it's important that each person be either in the first group or the second group, and not that they're kind of in between or in both groups. So, one factor multi-group design. This is B. You might do a study where you have 3 or more groups and the only variable is their score on your survey. So maybe you have people who consider themselves black, white, or Asian, or Native American, or they might be, I don't know, Pacific Islander, and they don't consider themselves Asian. Well, you could have multiple groups. That is very possible. You could have freshman, sophomore, junior, senior at a high school. That would be multiple groups, but it's still only your score on the survey. And then C, this is the one I promised you. I won't grade your charts and graphs because we can't go over it together in class. But I do want you to know what these things mean. Factorial design. This is C. You will not do this for your study because it gets too complicated. Let's pretend you have males and females, but then they are in 3 different groups. They work full-time, part-time, or not at all. How many groups do you have? Well, 6. That's called a 3x2 or 2x3 ANOVA. I have males that don't work at all. I have males that work part-time. I have males that work full-time. I have females that don't work at all, females that work part-time, females that work full-time. You see why that's more complicated. I now need 6 samples, 6 groups of people for that example. Main effects. Are my averages different? Overall, do males score differently than females? Overall, do people who don't work score differently than people who work part-time versus people who work full-time? That would be the main effects of my study. Are my averages different between groups? That's all you need to say. You don't need to draw the pictures. Interactions. If you did draw the pictures, I would want to know, do the lines cross? So again, it's hard to picture because we haven't drawn any of these together in class, but that's what it means. Do the factors interact with each other? So the question would be something to the effect of, oh yeah, males who work full-time, they scored really high in my survey, but females who work part-time, well, they scored really low, and then males that didn't work at all, they scored in the middle. You would see that your lines interact with each other. But I promise, you will not be graded on that for the exam. So moving right along. Within group designs, this is different because what we are talking about is a before and after. It's a dependent t-test. But you know what? If you happen to do before and after again and after that, you are now doing an ANOVA because you are doing multiple comparisons even though it's only one group before and after. Or in that case, before and after again. They often do this with stop smoking programs. What are you like before and after the program? Did you stop smoking? But what about a month later? What about a year later? Are you still refraining from smoking? So you can see how it can get a little bit complicated. So within group designs are dependent t-tests. So moving right along, what is good and bad? What are the advantages and disadvantages of only having one group of people that you're dealing with? Well, here's an advantage. It reduces variation. This is on page 90, by the way. In other words, I don't have to worry that my groups were different than each other. I only have one group. So I don't have to worry that my groups vary. It reduces variation. I only have one group. Second thing, it's more economical. if we were in class together, when I say economical, I bet a lot of people would be thinking money, economics. Well, you know what? It does save money to only have one group of people, but it saves other things too. It saves time, it saves effort, it saves stress, it saves how many people you need to employ at your business to do these kinds of studies in the real world. It saves a lot of things. And the last thing is power. Remember that 0.05 level from the previous week's material? It's so much easier to find significance at that level or any other level if you only have one group of people. For example, you get 20 people to take your survey and half are male and half are female. Guess what? You only have 10 in each group. But if you only have one group of people, it is easier to find the power to find statistical significance, like at the 0.05 level. Moving right along, 3 disadvantages to doing a dependent t-test or an ANOVA where you keep testing the same group over and over and over again. The 3 disadvantages: habituation. People get bored. Look for this on the test, by the way. They get bored, they get used to it, they get tired of doing the same thing over and over again. Habituation, habit forming. The opposite of that could happen too. Sensitization. You start feeling sensitive to it if it was something negative, like having your blood drawn once a week because of the medicine that you're on, or something else that is uncomfortable or unpleasant. So sensitization, maybe it's a side effect of a medicine. That could be sensitization. People are reacting because it was a negative experience. Again, look for that on the exam as well. And the third thing, order effects. If you're doing different treatments to people, like first you're giving them one medicine, and then after a month they can stop that medicine and do a different medicine, at the end of the study, you're not quite positive which one worked. Was it the combination of the 2 medicines, or that one was more helpful than the other? The same thing if you're trying to help people lose weight and get into shape. Is it their exercise? Is it their diet? Is it their lifestyle overall? If you keep introducing new things into the person's life, at the end of the study, it's not quite clear which one was the factor that really worked, that really made a difference. So order effects. Perhaps if you switch the order of things, your study would have come out completely different, or if you didn't do so many factors in the first place. That gets to the last thing that we are going to study today, and that is the very bottom of page 90. One factor designs, you could just do A1, again, not the steak sauce. We're talking about one factor, 2 treatment levels. It's just simply before and after, and whatever you do to them in the middle is the independent variable. But A2, multiple treatments. I am doing before and then after again, and then after that. I want to see if you're keeping the weight off, if you're staying away from the cigarettes, if you're practicing the same exercise habits, whatever. And then the last thing, we're almost done here. Another 2 minutes and we'll be done. B, multi-factor. That is the one that I was talking to you about a few minutes ago. If you change what you're doing to the people. First you're giving them exercise, then you're giving them a diet, then you're giving them lifestyle changes. At the end of the study, you're not sure which one made the difference, and that's why order effects is a disadvantage. Perhaps if you switch the order, things would have turned out differently. So B, multi-factor within subject design. What that means is that all of your subjects, it's a before and then after again, you are switching up what you're doing to them. Different treatments, different medicines, different kinds of counseling, different lifestyle factors, whatever. So that one is the most complicated, which is why it's not often used. So that is it for this one. The next video will cover the next topic. Thanks for watching.